It's time that we show you another way to solve a system of equations, and this works best when basically you already have one variable that's isolated. So let's take a look at 6 different examples. The first 4 will be normal problems. The last 2 would be dealing with the no solution, infinite solution. So here's an example, the first example. They give us these 2 equations and we want to go find the x's and the y's. And what's happening here that makes this stand out to say, hey, we want to use substitution method is because the y is all by itself here in the second equation. See the y right there? If you ever see one of the variables is by itself and it's equal to something else, that tells us that basically we can take that value, the y equals -6, and we can go to where we see a y in the first equation, and where we see this y, we're going to put in a -6. And that lets us be able to go and solve for what's remaining in that solution. So again, anytime that you see a variable that's isolated all by itself and it says what that variable is equal to, we're going to take that value and stuff it into the other equation. So let's go through and solve this. -3x minus 2 times y, and it says here that y is equal to -6, so we're going to put that in as -6, and now we're left with an equation that has one variable and we can go and solve that. Please remember that we're still following my guidelines of always attach that sign that's in front of the number. So we'll think of this as a -2. We'll think of this as a -6. So -2 times -6 is +12. And now after that little bit of multiplication, we have ourselves a two-step equation. And so we've got at least 1/2 of this SOE solved. We know what x is equal to, but we still have to look at it in terms of we want to go find x's and y's. And so as a result, we know that our x value is 6 and our y value is -6. Where did we get the y value from? It was actually given to us. So let's go down and take a look at the second example very quickly here. X equals -1. So since this variable is all by itself and we know that x equals -1, that's 1/2 of our solution. We have to go find our y. And so as a result, we're going to take our other equation, that 2x plus y equals 4, and where this x is, we're going to replace it with -1. And we go and solve. And so here we go. -1, 6, y equals 6, so that's what that is. X equals -1. This is our solution. So when do we use the substitution method? Basically when we see one of these variables isolated all by themselves. Now the next 2 SOEs that I've got for examples are a little bit different, and that's okay. We just want to get you used to it. This time the y is not equal to a number. It's equal to an algebraic expression, y equals -4x, okay? And that's still going to be very helpful. This y is all by itself. And what that means is that I can take this -4x value and replace it where I see the y down here. So let's see, -7x minus, because here's the minus sign right here. The y must be replaced with -4x. So I'm going to have to put in -4x right here. And now we just handle it like a normal equation. Are there like terms? There sure are. So it's a subtracting of a negative term. So keep, change, change. And this leaves us with -3x equals 18. And then we can divide by -3. and we're left with x equals -6. Now this is the first time that we have a variable all by itself where it equals a constant, where it equals a number here. And so my x value is -6. So I'll set that up for my ordered pair of my solution, but I still don't know what y is equal to. Well, let's look at it this way. We now know that the x is equal to a -6. So we're going to take this value and we'll plug it back into one of these equations. This is probably the easiest. -4 times -6. Well, -4 times -6 is 24. Y equals 24. So there's our solution for example 3. Very similar to what we did for the first two examples, where this y was isolated. We took its entire value and stuffed it into the other equation to solve what was remaining. After we got this value, though, we had to actually take this value for the x and plug it back in for the x in one of the equations to figure out what in the world our y value is actually worth. Now, let's go down to example 4. Y equals x. So anytime that you see a y, we're going to replace it with an x. So this y right here is going to be replaced with an x. -4x minus 3 instead of a y. That y is equal to an x. And now we can go and solve. -4 minus 3 is -7x. Divide both of them by -7. And x would be equal to 2. Now, let's stop and think about this. We know our x value. It's a 2. We take this value and we plug it into either one of these equations, but always try to find the easiest way. Well, this x becomes a 2, so y equals not x, but 2. So they equal each other. That's all well and good, but that's only handling what happens when there's an actual solution to these SOEs. We still need to deal with what if there's no solution or infinite solution. So let's take a look at a no solution. Now, the first thing I want to share with you is that when you dive into these problems, you still don't know whether there's infinite solution or no solution just looking at it. But let's take a look at this real quick. This y right here is equal to 8x. So just like we've been doing, we're going to substitute 8x in for a y down here. So let's go ahead and set this up. Now, we need to go ahead and multiply these together. This will be 16x. And it's right here where you start to get an idea that something is just different. -16x plus 16x is 0. I mean, there is nothing there. If there's nothing there, we put a 0. Does 0 equal 6? Nope. So that is why we would say there is no solution, because that is not a true statement. And then let's take a look at the last one. And let me back up here. When you get to the situation where there's no variables left over and there's two numbers left on either side of this equal sign, if these numbers are not the same, then it's a no solution. If these numbers were the same, we're going to call it an infinite solution, and that's what we're going to find on this last example that I have here, an example of infinite solutions. Wherever we see a y, we're going to plug in a -4x. So let's get busy with this part. -4x minus, here's the y, we're going to replace it with -4x equals 0. Keep change, so it's -4x plus 4x. Well, that leaves us nothing there. There's nothing else here, and 0 equals 0. See how the numbers are the same? We would say those are infinite solutions. Basically, these equations are exactly the same.